everybody for joining me this afternoon. Polina Vasilenko, you're the founder of Nantes-based Heliorec. Thank you for joining us.
Thank you.
You have to hold it very, very close to your mouth. You're a truly international person. Born in Russia, you studied and worked in Germany, my home country, in Portugal, Finland, and finally in France, where in 2019 you set up your company Heliorec. What technology do you produce, and where are your projects at?
Thank you very much for the invitation. It's very great to be here. Actually, I visited 70 countries, so I'm a super international person. Yes, and I came to France, opened my company Heliorec. We are developing floating solar power plants for near-shore locations. We are focusing in areas such as ports or industrial areas near the sea. So currently, we installed 2 projects, and 5 projects are under construction. So everything goes very well.
Okay, and what would you say are the main hurdles for your technology? Is it salt water, the wind, the waves?
Yes, obviously on the sea we have wind, wave, salt. In our case, we invented and patented Hydrolock feature. It helps to keep systems stable and robust. So idea of Hydrolock, we keep water inside the floaters, and this extra water gives extra mass. It works as ballast. And if wind will blow, system will not flip. So this is how we overcome wind problem. Regarding waves, we have flexible connectors from special rubber, and the floaters will flow together with waves. So we basically don't resist waves, we flow with waves. It helps us to survive with waves up to 2 meters at that stage. And regarding salt, for photovoltaic panels, we use special hydrophobic additive on top of the panel, and this additive helps to reduce the problem with salt. When we do the cleaning of the panels, it's much easier with this hydrophobic additive.
You're right now working on your first commercial projects, if I understand that right. Where do you see yourself in 5 years? How are you going to take this forward?
Yes, so we started to sell our system. We are working with well-known big companies. We are developing one project in Emirates, in Dubai, and another one will be installed in France. And in 5 years, hopefully, we will install 50 megawatt floating solar and will generate a clean energy for better planet.
Do you have interest? I mean, do you have people contacting you, companies contacting you, or ports contacting you from around the world, or where are your main markets?
As our company located in France, and our manufacturing, all components of floating system we manufacture in Europe, so in Estonia, in Sweden. We are targeting European market so far, and in a couple of years we will go to US. We don't plan right now to go to Asian market because we see a lot of opportunities in Europe, and we would like to develop technology here, install here, and we try to use as much as possible European panels, European photovoltaic equipment, cables, etc. As I said, we do manufacturing also here. So for us, main opportunities nearest years is here.
Okay, great. Well, thank you very much. Polina Vasilenko from Heliorec. In Beule, hello.
Hello.
You're an acceleration manager offshore at Belgium-based Tractebel, which is together with Jan de Nul and Demme developing Seavolt, right?
Yes, correct.
Can you tell us more about this technology, how it works, and that I understand salty water doesn't bother you. Is that right?
Yes. Thank you, of course, for presenting our key learnings. And Seavolt, yeah, you already see the movie starting. It's maybe a bit early, but okay, you can already watch to it. So yes, Seavolt is actually a company that is working together with Tractebel, Demme, and Jan de Nul. It's collecting 20 years of experience in offshore environment, offshore installation works, in solar power, but also innovative projects. So we're a very good team for designing, let's say this. What we see is of course the expertise that we put together. We have solar power above the waterline, very dry. We have a modular square system, easy, introduced and expanded. And it's also easy access. You saw the boat landing in the movie for cleaning operations. Together with that, of course, a large topside, a small floater design to have a good reproducible product. And why I'm saying I'm not afraid of seawater is, of course, we're above the waterline. We will not have splashing water of the sea. We also see, and that's I think common for the whole group here, that installation of onshore solar cells is also happening in the deserts. One example is, for example, in Chile, where they are installing in Atacama Desert quite close to the ocean. So even there, the solar cells, the commoditized solar cells, they can actually be used. We are going to install our test installation this summer, and it will be 1 year in the water, and there we will see the cleaning operations required, but we're very confident in our approach.
Where are you going to install the test installation exactly?
We're going to install in the North Sea area. We're actually putting together now our components, the floater and the top structure. And the test site will go into the water this summer. We drive it out from Belgium harbor to the North Sea area, so fully exposed.
And when are you hoping to reach the commercial stage?
The commercial stage will follow later on. What we do now is we see opportunities of installing demo projects in existing wind farms, reusing the existing cable and everything which is with that. And then later on, of course, we want to also incorporate it in existing wind farms, especially looking at the moment at the Netherlands, where there is already a section in the auction itself for 100 megawatt and even a promise for 3 gigawatt by 2030. So very happy to see what's going on in the Netherlands, and also happy to see what will happen in the future auction in France.
Absolutely. You already said that seawater doesn't really bother you. What are the main hurdles for you for this technology on a technology level, but also on a regulatory level, maybe?
Yeah. I know that solar power is coming maybe a bit later than wind and tidal and wave energy. And this is because we see the technology increasing and improving rapidly now. So more output means, of course, more benefit and more revenues. And for that, we see also that you can afford a floater to bring it offshore. What I see as main hurdles is, of course, you need to have your supply chain, which can be and will be very most likely different than the offshore wind, because you're talking about smaller units. And for that, that's of course a hurdle. You need to start it up. But I see it also as a positive point, because it's new people, it's new teams, and of course, that's the wind. There it's more difficult. It's already flooded with work. So introducing new factories, new people will only be a benefit for creating gigawatts offshore. I have another hurdle, of course, which is the environment. I'm not to say very pessimistic about that. We're doing multiple studies to see the impact of the temperature differences, the shading, and also the hydrodynamic effects. But with that, we see a very positive outcome compared to, of course, deployment on lakes, on rivers, where the impact, you see it already, is more massive than offshore. So that's on the hurdles.
Well, for now, obviously, floating solar is more expensive than offshore wind. Do you think that one day or when could come the day when this technology will be competitive?
Yes, I do believe, otherwise I would not be in this business, of course. What I see is, of course, the learning rate of the PV. Everyone, you can see it now. You can already produce more watts on the square area that is available. So that's already a positive point, and compared to wind, where you actually can only go bigger in size, and creating that problems with installation fleets needing to go bigger. If you look at fixed wind, then it will be, of course, a challenge to meet that. That I can confirm. But if you compare it to floating wind, I definitely see we can meet that target. Designing a floater for a turbine, 50 megawatt moving turbine, looks to me very more complicated than designing it for a floating unit for just solar cells. So that's I think, a very positive point. And last but not least, I hear everyone talking about multiple gigawatts required offshore. I think, yeah, that has to come fast for everyone. The supply chains are getting full. Everyone talks about it. What can be a possibility is, of course, introducing these fast gigawatts of solar power. And I want to conclude with 3 topics which are very important, I think, to drive the costs down. And yeah, of course, not only the costs, but 3 other topics which are very important to look at when looking at future auctions. So, sorry, that's what I want to say. Is that, of course, you need to look at also the speed that you can do the energy transitions, which is, of course, required to reduce the heating of the Earth. And, of course, also the multi-use, because wind is not always there, and you want to have power also when wind is not there. And last but not least, you look at using the area as positive as possible for much opportunities. And then if you combine solar with wind, it's a good competitive solution. Thank you.
Thank you very much, Kim de Beule from Tractebel. You, Aurélien Croq, you're the CEO of Paris-based SolarInBlue. Thank you for joining us today.
Thank you for the invitation.
And you have to hold the microphone really close to the mouth. In a nutshell, how does your technology work, please?
Okay, so basically, SolarInBlue is the leading French company pioneering floating solar. Thank you. So basically, we started the company in 2019. So we have 3 years of research and development now, and we have built a very strong DNA in offshore condition, harsh, challenging marine environment. So our technology is designed to withstand 10 meters waves and 200 kilometers wind, because we are looking at markets throughout the world for ports, for islands, and for co-location with offshore winds. So we definitely believe in the strong potential of the technology in many geographical and very challenging conditions. So that's why we have built this technological asset. So we have included in that asset all the main hurdles that we all have to cope with. So definitely corrosion, but we see that not really as a hurdle, but as a way to push us forward in terms of keeping capex low, because everybody knows how to cope with corrosion where there's infinite budget. But whenever you have a budget constraint and you want to keep capex as low as possible, then you have to make choices. So definitely our structure is able to integrate steel, but other materials also. And we have patented some interfaces between materials to make our structure corrosion resistant using several types of materials. We are aiming at a very long lifetime. The idea is that we have a production asset that is solar panels. These solar panels, they cost a lot. They are very precious to us, and we need to keep the environmental impact and the life cycle analysis as consistent as possible. So we want to use them for 30 years straight. So we have put them 3 meters above the sea level. We have a carpet effect of our farm, which means that the panels are never stressed by direct impact of the waves. They only experience the marine air, so they are kept really protected. And in terms of structure, we are aware, as the introductory person said, we are very much aware that we need to cope with an equation of 40 to 60 euros per megawatt hour to go commercial. And so we have made the choice of a very light structure, Tour Eiffel-like, which is very sober in terms of capex, but also very, very resistant. So we patented all this. And also we have a patent on the linkage of our floating solar units. And virtually, we have an infinite scalability with our technology. You can go 100 megawatt, 1 gigawatt, because the market potential we are looking at is huge, especially in collocation with offshore wind, because the two productions are very very complementary. And we strongly believe that there is a strong business case for floating solar.
And where are you at with your technology? You founded your company in 2019, right?
Yeah, so we started in 2019. So basically, we're a team of 7 engineers, so really focusing on the innovation, because we know that the success of floating offshore solar relies on our ability to reduce cost and to bring technologies that are sustainable on the long term with low maintenance. So our 3 years of R&D has brought us today to the first floating offshore wind farm in France. So it's located in Sète. We are demonstrating here, of course, the technology, the ability to produce solar energy at sea, but we are also demonstrating a business case. We are demonstrating that ports and coastal industries can benefit from solar electricity, and they can benefit it because we are competitive, and also because we have a very strong belief in social acceptability. And for ports and coastal industries, we know that there are some areas that are already impacted by industries, where there is little fishing, no navigation. And for example, here in Sète, we are located on the former station where they would unload oil from tankers. So you see there is a business case, a vision, and the technology that we bring here together in Sète. And we have the ambition to make it pre-commercial by 2024, 2025.
Okay. If I asked you the main question of this panel, what in your eyes are the main hurdles for this to go big?
Yeah. So I think, of course, the first one is how do you cope with harsh marine environment for your structure and your solar panels. So our view on that is you have to be very innovative in the materials you use in the structure to keep it sober and require low maintenance. You have to protect your solar panels to make them as if they were on the rooftop of a port, for example. We see also the challenges in terms of procurement. Also, in the person that did the introduction said that, and I strongly believe that procurement, local procurement, ability to build local jobs with floating offshore solar is very important. And we believe that we can build jobs locally as close to projects as possible. And I also see definitely the need to push the public authorities to go live on floating offshore solar as fast as possible. Again, we think that there is a lot of maritime land that is very socially acceptable because there's already, for whatever reason, no fishing, no navigation. When you look at offshore wind farms, for example, you know that for floating offshore wind farms, you have places where you have the cables, where you cannot fish, for example, you cannot do any fishing around the windmills themselves. You cannot have any activity. All these areas, we can help, there's a very strong rationale. It's already dedicated for energy production. Then you can make it even more efficient, split the connection costs, split the substation costs, costs, and all that. We think that due to the high social acceptability of floating offshore solar, definitely we can push the public regulation at French, of course, but also European level to go faster than what they did for offshore wind. And it's a need also, the introduction say that we need that. If we want to cope with climate change, if we want to decarbonize, we need to be very pushy. And we have the technology, we have the vision, we have the social acceptability. Let's go.
Sunny times ahead indeed. Thank you very much. Don Hoogendoorn, you are CTO and co-founder at Rotterdam-based SolarDuck. And you're going to take us to the Netherlands, one of the most, if not the most advanced country when it comes to floating solar. What's happening there?
A lot. We did good.
Very close to the.
A lot. We did a lot of lobby work in the Netherlands. So first years we were talking with the government mainly about the price, but recently they realized that they won't meet the Paris Agreement. So that triggered them to fully focus on offshore floating solar. So now the ambition is to install 3 gigawatts for 2030 on the North Sea, the Dutch North Sea alone. And that's now also they passed on that into tenders. So the first tender is now coming online. That's 2 gigawatts of floating wind plus 100 megawatts of floating solar. And it's expected next year to have a new tender of 2 gigawatts of wind plus 1 gigawatt of solar. So they're really pushing it. But it also brings, of course, challenges for the project developers to cope with these new technologies and all risks associated. But the key driver for the government is that a typical onshore project, a land-based solar project, is just 10 megawatts in the Netherlands. There's not so much space, and all the grid is congested onshore. And the farmer party in the Netherlands took a big stake in the last election. So that made them decide that offshore is the way to go. There's enough space, you can fit it inside the offshore wind farms. The assets are already there, like the substation and the export cables. So it's rather easy for them to install this offshore floating solar.
And I understand your company is going to try to get a share of that cake, right? The solar floating cake in the future. What kind of projects do you have?
Yeah, we already have one project together with RWE, the utility, the German utility. They recently won Hollandse Kust West wind farm. That's 700 megawatts of wind. And we will add 5 megawatts of solar. That will be commissioned in 2026, and that will be one of the biggest projects then on the North Sea. So that's very nice. But we also will join the tenders now on the North Sea, of course. Yeah.
If I asked you again the same question I asked all the other participants of this panel, what are the main hurdles for you for floating solar? You already touched upon that in your first or second answer. But are there any others you'd like to mention?
Yeah, there are many, of course, and that are little things and big things. For example, now in the Dutch law states that you can only export wind electricity to the shore. Yeah, that should be changed just in general electricity. It's a small thing, maybe it's one sentence, but can take, of course, 5 or 6 years before it's getting through the government. But also, like in other countries, more in Southern Europe, they're not so used to the sea and what they can do with the sea. So they should start developing tenders and frameworks to deploy these novel technologies, not only offshore floating solar, but also offshore wind and offshore floating wind. And that needs to be developed over the coming years. I think that's very important.
All right. Would anybody like to react to that, or?
Yeah, I think that regarding all the regulatory framework, we need also to work together on that because we share a common vision.
Okay.
We also all have partners, be it developers, be it utilities, who also strongly believe in the offshore wind. From what I see, and I think they all agree in professional events, everyone is very interested in the technology that we have, the vision. So we need to bundle, and get stronger as a whole and push forward the European agenda. We have islands in Europe. We have ports, of course. We have Fit for 55. We are the leaders of offshore wind. So definitely, we need to be the leaders of floating solar.
Yes, I fully agree on that, and I think it will be a bit like floating wind, where you have multiple designs that are being placed, and it will be the same for solar. So good to be here with with the big part of the technology providers.
Great, thank you very much. And we have a new drawing by Fanny, who has obviously summed up what we just heard here with her beautiful drawing. So she's talking about the challenges, wind, solar waves, that's obviously not bothering that much. Be innovative. There you go. There's a strong business case. As you said, Aurélien. Thank you very much. Thank you. Thank you, Fanny. Thank you for listening.
Thank you.